Hello, geometry. Welcome to lesson 9.1 on polygons in the coordinate plane. I love that this section is in 9.1 because it is after all of our triangles and quadrilaterals, and it's another way for us to revisit our good old friend, the distance formula. The OST loves distance formula problems. You're going to have to find the perimeter of something on the OST using coordinates. Let's just remember that coordinates come in x, y pairs, right? That's old news. Warning, there are going to be 3 videos for this lesson. I apologize. But again, it's a lot of computation using the distance formula. So it should not be that crazy difficult. Okay, so it says, what formulas can you use to identify properties of figures on the coordinate plane? So it says, what formula can you use to find A, B? So that is the length. So you could think of it as the length of segment AB, or you can think of it as the distance between A and B. Right? Those are the 2 ways you can read that A and B, which means if it's distance, you're going to use the distance formula. So what formula are we going to use? We're going to use the distance formula. Now remember that when I taught you the distance formula, I didn't do the long distance formula, which was this DE equals x2 minus x1 squared plus y2 minus y1 squared all under the square. I don't like that. Although some of you still use that, I don't like that. I just use Pythagorean theorem. Right? Pythagorean theorem. If I have a right triangle, or if I have 2 points, right? So let me do it like this. So if I have 2 points that I want to find the distance between, say a point here and a point there, right? This is the distance I want to find. Well, I just create my right triangle by drawing a horizontal and a vertical, creating that right angle. This is your x, this is your y. So to apply the Pythagorean theorem here, you're going to take x squared plus y squared and take the square root. So d equals x squared plus y squared under the square root. Again, it's Pythagorean theorem with it solved for the hypotenuse. So if I want to find AB, I'll do the same thing up here. I'll change colors. So here's AB. This is the distance I want to find. So here is my vertical. Here's my horizontal. This is my right angle. My horizontal is 2. My vertical is 5. So my distance of AB is equal to 2 squared plus 5 squared under the square root. 2 squared plus 5 squared is 29 under the square root. 29 is prime, so this is the answer, square root of 29. Be careful if it says decimals or exact values, and you might have to even simplify a radical as well. Perfect. So there's the first one. Next, same kind of picture, but it says now, what are we going to do to find if something bisects segment AB? Right? What point bisects AB? So we have to remember that when we're talking about bisects, it means splitting into 2 congruent parts. Splits into 2 congruent parts, in this case segments. But the point that splits a segment into 2 congruent parts is called the midpoint. We need to find the midpoint of segment AB. And we have what's called the midpoint formula. That midpoint formula is where you take the average of the x's. So you add the first x to the second x, you divide by 2. And then you take the average of the y's, you add the first y to the second y, and divide by 2. So in my picture here, let's let A be x1, y1. Let's let B's coordinates be x2, y2. We will plug them in to find the midpoint. 1 plus 3 divided by 2. 6 plus 1 divided by 2. That is 4 divided by 2 and 7 divided by 2. So you could answer it as 2, 7 halves or 2, 3.5. Either answer is acceptable. I should have done it in blue, sorry. And if you go up here and try to plot 2, 3.5, 1, 2, 3.5, boom. There's your midpoint M. A to M is congruent to B to M. Okay. last on this video, part C. So why do slopes of segment A, B, and BC show that an angle, ABC, is 90 degrees, right? So slopes. Why do slopes show 90-degree angles? Well, remember, if two segments form a right angle, that means those two segments are perpendicular. And for perpendicular lines, remember they have opposite reciprocal slopes. So if you find the two m values, you can then compare them and see if they're opposite reciprocals. So remember, to find slope, you can just count rise over run on a coordinate plane, or it's also equal to y2 minus y1 over x2 minus x1. You can do that as well. So this is your slope formula. So let's do that here. I'm just going to do rise and run. So let's do AB in blue. So the slope of AB. So I'm going to start at the rightmost point and go, or sorry, the leftmost point and go right. So I'm going to start at A, and I'm going to go down 1, 2, 3, 4, 5. So the slope of AB is down 5 and then right 2. So down 5 and then right 2. So that's a negative 5/2. And now in green, I'll do the slope of BC. So I will start at B and go to C. So I'm going to go up 2. So that's a positive 2. And then go right 1, 2, 3, 4, 5. And go right 5. So that's a positive 2 over a positive 5, which is 2/5. These two slopes are opposite reciprocals. One's negative, one's positive. 5/2, 2/5. Therefore, we know that segment AB is perpendicular to segment BC. And this angle right here, angle B, is a right angle. Okay, so there's your first video, and that kind of goes over distance, midpoint, and slope, the three formulas you need or to be able to use in this section. All right, next video is coming up.